What is up, grade 4, and welcome to this full maths lesson covering everything that you need to know about multiplication and division in grade 4. We're going to start by looking at a written multiplication method we call the expanded method. Then we're going to look at long division, and then we're going to look at the inverse operations, being able to flip between those two operations. Then we're going to look at how to multiply and divide by 10, 100 and 1000, before looking at the lowest common multiple and the highest common factor and how they can help us. Then we're going to look at square and cube numbers before looking at three very important rules of maths. The first one being BODMAS, the order of operations, then the commutative law, and then the distributive law. And that'll be it. You will be a genius with your maths, multiplication and division knowledge. Let's jump into lesson 1, multiplication, the written method. So today we're going to look at these two questions. We've got a green chili challenge of 43 times 25, and we've got a red chili, a harder challenge, 82 times 64. So let's begin with our green chili challenge, 43 by 25. Now the first thing we want to think about doing is making sure we're organizing our work nice and neatly before we begin. So I'm going to make sure I start by putting my ones, tens, hundreds, and then I can enter the numbers in the correct places. 43 times 25. Put my equals line, and I'm ready to begin, but let's just tidy that up. So let's begin. Now, where do we start? Well, we always start with our smallest values, and in this question we have a ones column. So ones will be our smallest value. So we're going to multiply our 5 times our 3 to start with. So my first question will be 5 times 3. Then I want to think about what's the second smallest value. Well, if I continue multiplying this 5, but move up now to my tens, I'll be multiplying 5 by 4. Well, it's not a 4, is it? It looks like a 4, but it's in our tens column, so it holds the place of 40. So my second question says 5 times 40. Now I've multiplied my 5 by the 3 and by the 4, which means that between my 5 times 3 and 5 times 40, what I've actually done is 5 times 43. Now I'm going to look at the second digit in this number, the 2. And we know it's not a 2, it's actually a 20. So my first question should be 2 times 3, but like we say, it's not a 2, it's a 20. So 20 times 3, and then my last question would be 2 times 4, or 20 times 40. And now I'm ready to begin. So here goes. 5 times 3 is 15. 5 times 40, well, I might not know that, so I can just use my knowledge of place value and put my 0 in place, and then just do 5 times 4. 5 times 4 is 20. So the answer to 5 times 40 would have been 200. Now I've got 20 times 3, again, put my placeholder in place. 2 times 3 is 6. My next one says 20 times 40. This time I've got 2 placeholders. So I put 2 placeholders in place, and I can do 2 times 4 is 8. Looks finished, but is it? No, not yet, because so far we've partitioned our number, we've broken it all down into the individual parts. Now I need to smash it back together to add it all up. So now I'm going to add up all of these individual parts. So if I start with my ones, I've got 5, 0, 0, 0, that equals 5. And if I then look at my tens, I've got 1 and 6, that equals 7. And in my hundreds column, I've got 2 and 8, that equals 10. So my answer is 1075. Okay, so my next question is a red chili challenge, one that's a bit harder. Why is it harder? Well, these numbers might be a little bit harder to multiply. So let's start at the right place. Let's put our ones, tens and hundreds, and then we put our numbers in place. 82 times 64. Put my equal line, and I'm ready to begin. But let's just tidy it up. There we go. Okay, so let's remind ourselves, where do we start? Well, we start at our smallest value, so my first one's going to be 4 times 2, and then I start moving to the next smallest value, 4 times 8. Not an 8, is it? We know it's an 80 because it's in the tens column. So now I've done the 4, I'm going to move on to the 6, and I'm going to do 6 times 2, but we know it's also not a 6 because it's in the tens column, so it's 60 times 2, and then my last question would be 60 times 80. Put my equals line, and I'm ready to begin. Here we go. 4 times 2 is 8. 4 times 80, not sure, so I'm going to use my place value, put my 0 in place. Now I can do 4 times 8. 4 times 8 is 32. Put that in place. So 4 times 80 is actually 320. Now I've got 60 times 2. put my placeholder in place. 6 times 2 is 12. Now I've got 60 times 80, I've got 2 placeholders, 1, 2, 6 times 8 is 48. Okay, and then we can just simply add those columns up. 8 plus 0, 0, 0 is 8, 2 add 2 is 4, 3 add 1 is 4, add the 8 is 12, so carry a 1 over, 4 add the 1 is 5. So my answer to the red chili challenge is 5,248. Wow, well done. If you carried along with me with that, that shows you've got a good understanding. Let's think about the things we need to remember. Always put your ones, tens and hundreds as your column titles. That's going to help you avoid any mistakes. Partition the question into all of its individual parts, like we did here, where we thought about our 4 questions first. 1, 2, 3, 4. That's really important. Don't forget your placeholders. It's going to make the multiplication much easier. And then don't forget that you've individually answered these separate parts. You must put it together to get a final answer at the end. Okay, I've got 3 questions here on the board for you. I want you to have a go at all 3 of these. Put the answers in the comment section and I'm going to try and mark every single one. Good luck. Okay, that was multiplication written method. Now let's look at a written method for division, and we call it long division. Let's go. We're going to first start with this question here. It says 36 divided by 3. So the first thing that we're going to do is put our 36 inside what we call this bus stop, and we'll put the 3 on the outside. And we call this 3, this is the divisor, and the 36 we call the dividend. And what we're doing here is we are sharing our dividend between our divisor. We need some steps to help us answer this. And the first step is going to be to divide. And then we're going to do step 2, which is to multiply and find out how many we took away from our 36 each time. Then we'll subtract that group, and then we'll pull down the next digit and work on the next column. So let's see what that looks like. Okay, so the first question does say how many 3's are there in 3, because I'm dividing my 3 by this 3 here, but we know it's actually a 30. And I know the answer to how many 3's are there in 3 will be 1. There is one group of 3 in 3. If I had 3 marbles, then I could take one whole group of 3 away. Okay, and now what does step 2 mean? Multiply the groups. Well, what I'm going to do is I want to work out how many of my 36 I've just worked out in that first step. So if I times 1 by my original 3, I'll get 3. 1 times 3 is 3. If I subtract that from my question, I will end up with a 0 in this tens column, and then I can pull down my 6 and I will end up with a 6 in the ones column. Now I can go back and do step 1 again, divide. So how many 3's are there in 6? Well, there are 2 3's in 6. Okay, but I'm not quite finished. I need to do step 2, which is to find out how many groups I've just taken away. So 2 times 3, take that away, leaves me with 0. And this is what we call the magic 0, because this is what we want to get down to at the end of this kind of question, because that shows us that we've finished this question and that we have our final answer. So 36 divided by 3 equals 12. Good job. Okay, let's move on to a slightly harder question. Let's have a look at this question here. 656 divided by 4. So we're going to have the same steps again, and I'm going to put my dividend of 656 inside my bus stop and my divisor 4 on the outside. And I can just do the same thing again. So how many 4's are there in 6? Well, if I have 6 marbles, I can take one group away. I couldn't take another group because I haven't got a full group of 4. So I've got 1. But now when I do my multiplication to find out how many groups, we're going to get a slightly different result. So let's do it. Let's see. 1 times 4 is 4. And that's going to leave me with 6 subtract 4 is 2. Now I can bring down my next digit. I'm not going to bring the 6 with it. I'm just going to bring the 5 at this point. And I have 25. Now I can ask myself, how many 4's are there in 25? So 4's into 25, we can count up in our multiplication table if we want to try and do it that way. 4, 8, 12, 16, 20, 24, and I can't go to 28 because that would be more than 25 and that would be too many. So the answer is 6. And let's see how many we took away that time. So 6 times 4 equals 24. Take that away and I'm left with 1. Bring down my 6 and I'm ready to answer my final part. How many 4s are there in 16? 4, 8, 12, 16, we have 4. Now I can do my 4 times 4 and I work out that that's 16. That 16 subtract 16 is 0, my magic number, meaning that we've finished this question. So 656 divided by 4 equals 164. Good job. Okay, let's look at a slightly different one. This one's going to be a little bit tricky. Let's have a look at 146 divided by 5. Okay, so same thing again. I'm going to put my 146 inside my bus stop and my 5 on the outside. And I'm going to follow step 1 again. So how many 5s are there in 1? Well, if I have 1 marble, I can't take any groups away, can I? So the only thing I can do is put a 0. I took 0 groups away. But now, when I do my multiplication, I can work out that 0 times 5 is 0. I took 0 groups away. 1 subtract 0 still leaves me with 1. Bring down my 4, just like before, and now I have 14. Now I can ask myself, how many groups of 5 are there in 14? 5, 10, 15. 15 is too far, so I have to stop at 10, so therefore there's 2 groups. 2 times 5 is 10. Subtract the 10 leaves me with 4. Bring down my 6. How many 5s are there in 46? Again, we're going to use our times table knowledge. 5 times 9 is 45, so there's 9 lots. But then when I do my 9 times 5, I see that I have 45. And when I subtract that, I'm left with 1. And if we remember, there are no groups of 5 in 1. So I can't do another division. What I have to do with this 1 is consider it a remainder, 1 left over. So my answer is 29 remainder 1. So the answer to 146 divided by 5 is 29 remainder 1. If you want to learn how to change this remainder into a decimal, you can watch that video on this channel as well. Okay, let's do our final one. Let's do a big one. We've got 3,986 divided by 6. Okay, same process again. I don't think this is any harder, just a little bit longer. So here we go. First question is, how many 6s are there in 3? There are 0, and therefore 0 times 6 is 0. Subtract that away from my 3, and I still end up with 3. Pull down my 9 to answer the next question. How many 6s are there in 39? 6, 12, 18, 24, 30, 36. Can't get to another number, so we have 6. 6 times 6 is 36. Subtract 36 from 39 leaves me with 3. Now I can pull down my 8. And my next question says, how many 6s are there in 38? 6, 12, 18, 24, 30, 36. I can't go any higher than that again, so I have 6. Again, 6 times 6 is 36. 38 subtract 36 is 2. Bring down my 6. How many 6s do we have in 26? I have 6, 12, 18, 24, so I can take 4 whole groups away, and 4 times 6 is 24, leaving me with 2. 2 is smaller than 6, so therefore we can't take a group of 6 away, so that's going to become a remainder. Simple. So there we go, that's our written method for multiplication and division. Let's see now how they can intertwine and look at the inverse of them. Let's jump into it. Okay, we're going to be looking at two different style of questions here. We've got our green chili challenge, which is just a division question, and we're going to inverse it into a multiplication. And then we've got a missing number problem as well that we're going to see how inverse can help us solve. Okay, so let's start with our green chili challenge, our first question. So we have 15 divided by 5. So we know that if we have 15 divided by 5, we're going to get an answer of 3. There are 3 5s in 15. So what does inverse mean? Inverse essentially means the opposite. So division is the opposite of multiplication. So we can use these same numbers to create another number sentence, which is multiplication. So let's see how we can do that. But let's have a little think about what we know about number before we start. We know that when we're dividing a large number by a smaller number, we are going to get another small number, a number smaller than our first starting number. Therefore, it's logical to think that this number here, the 15, if we are making a multiplication question, will end up being the answer because two smaller numbers multiplied together will equal the bigger number. So therefore, my number sentence for my multiplication would be 5 times 3 equals 15. And let's check it, 5 lots of 3, yes, equals 15. But I can see another number sentence here that would also work. What if we flip the 5 and the 3 around and we used our commutative law? And I put 3 times 5, and I also know that 3 times 5 equals 15. So using the same numbers, so far I've made 1, 2, 3 separate number sentences. Well, I can actually see another one. I can see another division question because I think that if I get my 15 at the start again, and this time I divide by 3, I'm going to get 5. So with the same set of numbers, I've actually managed to create 4 number sentences. And these 4 number sentences together are called the number family. And every question will have a number family, a different way of expressing the numbers using different operations. In this case, we have 2 multiplication and 2 division questions. Let's have a quick look at another one. Let's say I have 25 times 4 equals 100. Okay, so if now I'm wanting to find the opposite, the inverse, I can try and think about my number knowledge again, and I can see that my larger number here is 100. So if I'm wanting to create a division question, I'm going to need to put my larger number at the start. So now I can have 100, and knowing what I know now about my number family, it doesn't matter which way around I put my 25 or my 4 because it's still going to be part of the number family. So I can say 100 divided by 25 equals 4. Or I could write 100 divided by 4 equals 25. Can any of you see the other question that I can have in this number family? I have 2 division and 1 multiplication, which means it must be another multiplication. And yep, I can see it here. I could have 4 times 25. Move those 2 numbers the other way around and I'll still get 100. Okay, so let's use that knowledge to try and help us with this missing number fact then. So here I have a question that says 12 times something equals 48. And this is a very common question that you're going to see in exams. So I can see this is a multiplication question. So I know that this number and this number will both be smaller than my 48. So therefore, for a division question, I'm going to put my 48 at the start. And I can simply use now the only number that I have available to me, 48 divided by 12. And I know that 48 divided by 12 is 4. Now I can check my answer by doing 4 times 12 should equal 48, which it does. So I've got now 1, 2, 3 of my number sentences. I can now get my other one, my other division question, by putting 48, but instead of dividing it by 12, I'm going to divide it by 4, which equals 12. But the one that really helped us was this one here in order to get our missing number. Let's have a look at another quick missing number. Let's say I put 50 and I divide by something, but it equals 10. And this one's a little bit different because I actually don't need to do the inverse operation because I have one of my division questions, but if I simply put my other division question, which would be 50 divided by 10, still in the same number family, that's going to equal 5. So therefore this question mark here could be replaced with a 5. Let's check it. 50 divided by 5 equals 10. Correct. Let me quickly get my next 2 number sentences, and I can see that 50 is the largest number. So if I'm now going to multiply, that number needs to come to the end, and I could work out that 5 times 10 equals 50, but also flip those numbers around, 10 times 5 equals 50. These are my number family. And there you go. That is using the inverse operation to help you solve both missing number questions and also being able to just check your answers and make sure you've got the correct answer. Let's think about the things to remember. Firstly, inverse essentially just means the opposite. Multiplication is the inverse of division, and addition and subtraction are inverse of one another. And then lastly, a number sentence can have a number family, and those number families can help you with all of what we've just been talking about. Okay, so now it's your turn. I would like you to try and find the 4 number family sentences for these 3 questions. Once you get them, put your answers in the comment section. I'm going to try and mark every single one. Good luck. All right, now we're going to look at multiplying by 10, 100 and 1,000. That might seem tricky, but there's a really good trick to do with our place value knowledge. Let's jump into it. So what does it mean to multiply by 10, 100 and 1,000, and why are we grouping this into one lesson? Well, the reason we do that is because these are a special set of numbers that are actually quite easy to multiply and divide, so therefore learning a little trick or a method to do this is going to be very, very helpful. So what is that method? Well, we're going to use the place value chart. And I've got one here for us. We can see our ones, our tens, our hundreds and our thousands. We've actually got things below the decimal as well. This is our decimal line, and then we have tenths, 100ths and 1,000ths. So how can this help us? Well, let's take our first question here, the 56 times 10. The first thing we're going to do is we're going to put our 56 into our place value chart, really focusing on the value of these digits. So in 56, I know that I have 6 ones. So I'll put my 6 in the ones column, and I know that I have 5 tens, so I'll put the 5 in the tens column. Now, when I multiply it by 10, what I'm actually doing is making this number 10 times larger. So to show that, I can just move it one place up this place value chart. And by doing that, I'm making this number 10 times larger. Let me show you what I mean. If I move this 5 into this column, and I move the 6 into the tens column, then I end up with 5 hundreds, 6 tens, and although there's nothing in my ones right now, I would have to fill it with what we call a placeholder or a 0. And now my answer says 560, and 560 is 10 times larger than 56. That's quite easy to see. So my answer to 56 times 10 is 560. Okay, let's see if this can help us with our division question. So now I have 530, and I'm going to put that into my place value chart again. 530 has 0 ones, 3 tens, and 5 hundreds. And this time I'm dividing it. And when we divide something, our number is obviously going to be getting smaller. So this time we're going to move down our place value chart or to the right. And if I'm dividing it by 10, what I'm actually doing to this number is making it 10 times smaller. So here we go. I'm just going to move them one place to the right this time. So now this 0 will come into this column, into the tenths. The 3 will go into the ones column. The 5 will go into the tens column. And I'm nearly finished. The only thing I need to make sure I do is put my decimal in place, because remember, this line here represents our decimal place. So my answer is actually now into the decimals, and I've got 53.0. Now anybody that understands number will understand that we actually now don't need to include this 0.0 in our answer. I can simply write 530 divided by 10 equals 53. Because this 0 doesn't change the value of my number at all. I could have a 0 here, 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 all down my place value chart, and it's not going to change the value of my number. Okay, let's turn things up a little bit. Let's get an orange chili challenge. I'm looking at 23 times 100, and I'm going to put my 23 in place just like before, but this time I'm multiplying by 100. And when I do that, I now need to make our number 100 times larger than what it is. So to do that, I'm going to move it not just one place up our place value chart, but 2 places. And I can see that because I have 1, 2 zeros in my 100. So to make it 100 times larger, here we go, let's move them 1, 2 places. So my 2 moves 1, 2 into the thousands column, and my 3 also moves 1, 2 into my hundreds column. Now remember, we've got some blank spaces here before my decimal, So now I need to fill them with placeholders or zeros. Show me that the answer to 23 times 100 equals 2,300, because 2,300 is 100 times larger than 23. Okay, so let's look at our division question. 453 divided by 100. But now I'm dividing, so remember I'm going to be going down the place value chart to the right. How many times am I going to go to the right? Well, I'm dividing by 100. I need to make it 100 times smaller, so I'm going to move it 2 places, which will make it 100 times smaller. So here we go. I move my 3, 1, 2. I move my 5, 1, 2 into the 10th column, and I move my 4, 1, 2, landing in the ones column. Don't forget to put that decimal, that's super important. 453 divided by 100 leaves me with 4.53, or 4.53. Let's get to that real spicy challenge. Here we go. 87 times 1,000. So same rule applies. I'm going to put my 87 in place, but now I'm multiplying by 1,000. So how many places am I going to move it to my left? Because remember, when we're multiplying, we move it to the left because we're getting bigger along our place value chart. Well, I'm going to look at my 1,000. I can see I've got 1, 2, 3 zeros. So therefore, I'm going to move it 3 places to my left, making it 1,000 times bigger. So here we go. 8 moves 1, 2, 3. I'm coming actually out of my place value chart that I've made, but that's okay because the place value chart can go on forever, and this column here represents 10,000s. Okay, so my 8 lands in here. I'm going to do the same thing to my 7. 1, 2, 3, and now I have these 3 gaps before my decimal that I now need to fill with placeholders. 1, 2, 3. So my answer to 87 times 1,000 equals 87,000 and no decimals. Okay, let's do my last division question. Here we go. And this time I'm dividing, so I need to come down my place value chart because remember, division questions will end up with a smaller answer. And I'm dividing by 1,000 again, so I have 1, 2, 3 zeros to consider. So I'm going to move them 3 places down my place value chart. But I can see here that I can put my decimal in place, and I have a couple of options. I can call this number 0.421, or I can put a 0 here and call it 0.421. Exactly the same value, just a slightly different way of saying it. So I'm going to keep my 0, and I'm going to say 421 divided by 1,000 equals 0.421, or 0.421 thousandths. Okay, there you go. That is everything you need to know about multiplying and dividing by 10, 100, and 1,000. But let's just look at what to remember. First, we should always make a place value chart. Then write the numbers in the chart focusing on the value of each of the digits. Then move the numbers to the left if we're multiplying, or to the right if we're dividing. And then we simply look at what we're multiplying and dividing by, 10, 100, and 1,000, see how many zeros are in that number, and then move the numbers that amount of times. Okay, so now it's your turn. Press pause on the video, have a go at answering these questions again for yourselves. If you need a little bit of help, you can go back and see how I did it in the video, but try and do it on your own. Put the answers in the comment section. Okay, now we're gonna get into some tricky stuff. We're gonna look at the lowest common multiple and what that means and how that's gonna help us in other forms of maths. So strap your hat on, let's go. Okay, we're going to look at these 2 questions, 5 and 12 and 3 and 11. But before we do that, let's first think about what lowest common multiple means. And let's think about it word by word. So multiple. A multiple means any number that is in the multiplication table of our given number, the number that we're discussing. In this case, 5 and 12. So think about the numbers that are in the 5 times table, 5, 10, 15, 20, 25. They are all multiples of 5. And 12, 12, 24, 36, they are all multiples of 12. So a multiple is just the numbers that are in the multiplication table of the number that we're thinking about. Or a fancy way to think about it is a multiple is the product of our number multiplied by any integer, an integer being a whole number. So for example, 5 times 3 equals 15. 15 is the product, 3 was the integer we multiplied our number by, and therefore 15 is a multiple of 5. Okay, Common just means the same, together. So it means if I'm trying to find the common multiple, it wants me to find how many multiples are in both the 5 and 12 times table. And lowest simply means the smallest value. So we're looking for the smallest number that's in both of our multiplication tables. Okay, let's begin with question 1 then. And I have 5 and 12. So I'm looking for that common multiple, the lowest common multiple. So I need to think about what my multiples are. Let's think about our 5 times table. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Let's stop there. And now let's think about our 12 and think about the 12 times table. So I would start with 12, 24, 36, 48, and 60. Okay, so I found my multiples, and now I think I've found a common multiple. I have this 60. And what I can also see that this is the only multiple that I have here, so therefore it is my lowest common multiple. So I could have carried on and I would have noticed that I would have also 120 in both of these multiplications, but that would not be my lowest common multiple because it's not the smallest number. The smallest number would be this one, the 60. So if we're looking at 5 and 12, the lowest common multiple, and we can say it like that, LCM equals 60. I give myself a tick. Now what you might notice with our lowest common multiple being 60 is that 60 is actually 5 times 12, our two numbers. 5 times 12 is 60. So we know that 60 was going to be a multiple, but we don't know if this is our lowest common multiple. So I'm not going to use this method. This method's great for finding a multiple, any multiple, but we don't always necessarily know it's the lowest common multiple. So it's much better to write down a sequence of our multiplication table so we can make sure we get the lowest common multiple. Okay, let's move on to question 2 then, and we have 3 and 11. Now what I think is quite a good tip is to multiply the bigger number first. So I'm going to find some multiples of 11. 11, 22, 33, 44, 55, and I'm going to stay there. And now I'm going to look for those multiples of 3. The reason I think this is a good idea to do it this way around is because now I know when to stop in my 3 times table, because hopefully I will bump into one of my multiples in the 11 table before I have to do too many. So let's go. I'm going to have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Okay, what have I found? I think I found a common multiple. I found 33 in both the 11 times table and in the 3 times table. Now I can see that there's no multiple that's less than that in any of these digits, so therefore the lowest common multiple equals 33. So to find our lowest common multiple, all I need to do is try and draw a list of the multiplication table of both the numbers, find the ones that are common, the ones that are the same, and then look for the lowest one. Okay, I hope that was useful. Here are 3 questions for you. Try and find the lowest common multiple of all these sets of numbers and put the answer in the comment section. I'm going to try and mark every single one. Okay, that was the lowest common multiple. Now we're going to look at the highest common factor and see how that can then help us in maths. Ready? Let's go. Okay, so where are we going to begin? Well, we're going to look at what the phrase actually says first of all, and we're going to think about these 3 words. Let's start with factor. So what is a factor? Well, a factor are any 2 numbers that when multiplied together equal the product of the number that we're talking about. So in this case we have question 1, we're looking at number 6 and number 15. So if any number multiplied together equals 6, they would be the 2 factors, and again for 15. So that's what factor is. Common just means the same, so we're looking for factors that are both in 6 and in 15, and the highest obviously means the highest, the biggest number, the greater value. Okay, so let's put that into practice a little bit and let's have a look at question 1 and let's have a look at these 2 numbers. So we're trying to find the highest common factor of 6 and 15. So first of all, let's look at the factors then. So if I have the number 6, how can we find our factors? If you haven't checked out the multiples and factors video on this channel, then this is your time to do that, because we're going to go quite quickly through what factors are here and how to find them, but there's much more description in that other video. So we know that the factors are two numbers multiplied together equals 6. So we can always start with 1 and 6. We know that 1 times 6 is always going to equal 6. So therefore 1 and 6 are both factors of 6. Okay, let's see if there's any more. Go logically in sequence. 2, and I know that 2 times 3 will also equal 6. Now let's see if I can go any further. Well, if I put 3, we know because I've got 3 here and I've already used a 3, that is as far as I should and could go. So my factors of 6 are 1, 2, 3, and 6. So now we need to look at 15. So if I put 15 over here, what are my factors of 15? Well, I know I have 1. 1 times 15 will equal 15. Have I got a 2? No, because 15 is not divisible by 2. I can't divide 15 by 2. So I have no 2. What about 3? 3 times 5 equals 15. What about 4? Is 15 divisible by 4? 4, 8, 12, 16, so no. And then if we try and use 5, I've already used a 5, so I don't need to do that. So let's have a look. Our factors of 15 are 1, 3, 5, and 15. Okay, so now that I found my factors, now I need to look at my next word, the common factors, and let's see which of those are the same. Well, in both of these I have a 1. In both of these I have a 3. And that's it. Okay, so I've found my common factors. And lastly, I'm looking for my highest common factor. So my highest common factor in this case is 3. So the highest common factor equals 3. Awesome, let's have a look at another question. Let's have a look at 8 and 16. So first of all, let's look for my factors of 8. I have 1 and 8, 2 and 4, 3 and 3, 6, 9. Nope, no 3. And if I try and do another 4, I'm just repeating myself, so I don't need to do that either. So here are my factors of 8. 1, 2, 4, and 8. Awesome. Now let's look at my factors of 16. I have 1 and 16, 2 and 8, 3. Is 16 divisible by 3? 3, 6, 9, 12, 15. No, doesn't look like it. So 4. And then what do we multiply 4 by? Another 4. So therefore, I know that I've come to the end because I've already now used that other 4. So my factors of 16 are 1, 2, 4, 8, and 16. Now let's look for those common factors. I have a 1 in both. I have a 2 in both. I have a 4 in both. I also have an 8 in both. So then now looking for my highest common factor, I can see that 8 is my highest common factor. Awesome. Okay, hopefully you're getting the gist of this. Let's finish off with question 3, which is 5 and 10. So let's start with 5. Factors of 5 would be 1 and 5. And then, do I have any more? 2. 2 times nothing. 2, no, 2 doesn't work. 3, no, 3 doesn't work. 4, no, 4 doesn't work. So we're back to 5. Well, we've already used our 5 and our 1, so we can't do that. So therefore, I only have these 2 factors. That makes 5 a prime number, which we're going to talk about more in our next video. Okay, so we only have these 2. Let's see what we have for 10. I have a 1 and a 10. I have a 2 and a 5. And then I think that might be it. 3, no, 4, no, and then we're back to 5. So my factors of 5 were 1 and 5. My factors of 10 were 1, 2, 5, and 10. Let's look for those common factors, and hopefully we can see we have a 1 that's common, and we also have the 5 that's common. Let's find the highest common factor, which we can now see is the 5. So the highest common factor equals 5. Awesome. Okay, well, hopefully this was useful for you. So what we're looking for, the highest common factor, first look for those factors, Then let's find the common factors between the two and then just look for that highest value, the biggest number. Okay, so here are 3 questions for you. Have a look at trying to find the highest common factor for these. Put your answers in the comment section. I'm going to try and mark every single one. Whoa, they were 2 difficult lessons. Now let's have a look at something a little bit different. Let's have a look at what a square number is and how we can use that in mathematics. Okay, the first thing we need to understand is that squaring a number is essentially just multiplying the number by itself. So let's have a look at what that means. And let's have a look at this question here. We have 3 squared. So 3 squared is asking me to multiply this number by itself. So before we do that, let's just understand what these parts of the question are. The 3 is what we call the base, and the 2, the exponent. And what I'm trying to do when squaring is multiply my base by itself, the amount of times the exponent is telling me to. So in this case, I'm multiplying 3 by 3. So my number sentence will look like 3 multiplied by 3. And we obviously know that 3 times 3 is 9. So my answer to 3 squared is 9. But at this point, I want to show you what this actually means and why it's called squared. So I want to build a square here, and my square is going to have a width of 3 and a length of 3. Now if I get my square and now I cut it into its widths and length, so I've got 3 vertical squares and 3 horizontal, I can now see that my internal amount of squares equals 9. And that's essentially what we've just done. We've squared our number. So another way of thinking about how to square a number is how many squares would fit into that larger square if that large square has a width and length of our base number. So in this case, our base number was 3, so I've done a width and a length of 3, cut my square into those individual squares, and I got 9 as my answer. Let's have a look at it with another example. I have 5 squared. Now at this point, I want to share with you a very common mistake that people can make. In this scenario, a lot of people would multiply 5 times 2 because they think they multiply the base by the exponent. And that's going to give us an answer of 10, which we can obviously see is wrong straight away. So my number sentence should actually read 5 multiplied by 5. And 5 times 5 is 25. Let's prove it again by building my square. 1, 2, 3, 4, 5 in length and 5 in width. And now if I cut this up into the individual squares, I can see that my internal amount of squares equals 25. Proving that 5 times 5 is 25 and that 5 squared is also 25. So hopefully this makes sense to you that 5 squared is essentially saying that we get a square with length and width of 5 and basically work out how many smaller squares we can chop that into using those measurements. Let's have a look at our last one, and we're going to do this without building up our square. We're going to do this the quick way. 9 squared is the same as saying 9 multiplied by 9, and 9 nines are 81. So the answer to 9 squared is 81. And if I was to take the time and build up my big square, we would be able to prove that. Okay, so what do we need to remember about how to square a number? Squaring a number is multiplying it by itself. And also, we call it squared because it is the result of chopping a square into those smaller squares. So now it's your turn. Have a go at trying to answer these 3 questions. Put your answers into the comment section and I'm going to try and mark them all. Good luck. Okay, that was square number. The natural next step is cube number and what that means. And there's actually a little trick to it as well. Let's have a look. But first, let's have a look at what cubing a number actually means. So as you can see here, cubing a number actually just means multiplying a number by itself 3 times. So if we have a look at this first challenge here, 3 to the power of 3, we should first understand that this 3 is called the base. And this little 3 up here, the power of, we call the exponent. But in some places we know it to the power of, so we might say 3 to the power of 3, or 3 cubed. So, as it says here, to multiply the number by itself 3 times, what we should do with 3 cubed is say 3 times 3 times 3. And with a small number like this, we can work this out reasonably quickly. We can do 3 times 3, which is 9, and then 9 times 3 is 27. So that's pretty straightforward. 3 cubed equals 27. But I want to take the time to show you why it's 3 cubed and why it's 27 and what it all actually means. So if we draw a cube with a length, a width and a height of 3, so we have 3 this edge and 3 this edge, and I can draw it in its 3rd dimension, and let's say we've got 3 down this back edge as well, we can see that when we chop it all up into its squares, that we have 9 on the first side, which is that first part of the question here, which is actually 3 squared. So 3 squared is 9, and then to find the cube, we would then multiply it by another 3 because we're actually going 3 deep. So we have this first row of squares, then we would have the next column, and we'd have a third column. So we have to multiply that 9 by 3. So that's essentially what cubing means, but I promised you a quick way of getting there for numbers between 11 and 19. So let's have a look at this question here. Question 2 says 12 to the power of 3, or 12 cubed. So let's have a look. 12 cubed. Now the first thing we're going to do in this little trick is we're going to look at this digit here, and we're going to turn the digit into a letter. We're going to call the letter B. And then to work it out, what we're going to do is we're going to include the 1. So we'll start with the 1 here, and then we're going to have B, and then we're going to have B squared, and then B cubed. Once we've got these, the middle 2 we're going to double. Okay, so let's see what I mean, and let's work it out over here. So first one was 1. Then we need B. Well, B is just 2. And then we need B squared. B squared is 4. And then we need B cubed. And B cubed would be 2 times 2 times 2, which is 8. But like I say, we're going to double these middle 2 values, the tens and the hundreds column. So 4 doubled would be 8, and 2 doubled would be 4. And now I'm simply just going to add this up, treating it like any other addition question. So in my ones column, I have 8 and nothing, so that would equal 8. In my tens column, I have a 4 and an 8, which would be 12. I'm going to carry the 1 across, bring my 2 across. In my hundreds column, I have now a 1, 2, and a 4, equals 7. And then in my thousands column, I have just a 1. And there you go. This is the answer. So the answer to 12 cubed equals 1,728. Do you want to see another one? Let's have a look. So let's have a look at 15 cubed. But this one's a little bit trickier, so just be careful when you're putting your numbers in the columns. But we're going to follow exactly the same process. We're going to first label this 5 a B, and then we're going to have a 1 to represent our first 1, then a B, B squared, and B cubed. Now I can work it out. So I have 1, B on its own is 5, and now I can do B cubed, and B cubed is 25. But I only have 1 column width, so I'm going to put my 2 in this column over here, the higher value, and the 5 into the tens column. And that's the little detail that can be a little bit hard for people to remember. Let's do B cubed. Well, B cubed is 125, so now we've got even further to go backwards. Let's put my 100 in the hundreds column, my 20 in the tens, and now my 5 in the right column. Okay, but remember, we double the value of these 2, so let's do that now. Double B is double 5, which is going to be 10, so I'm going to put 1 in this column and a 0 in this column to show 10. Double B squared is double 25, so that's 50, so now I'm going to put a 5 in this column and a 0 in this column. So it's starting to get a little messy, but not out of control yet. Okay, now I'm simply going to add it up. Let's do it. In my ones column, I've just got a 5. In my tens column, I have a 5 and a 2, 7. In my hundreds column, I have a 2, a 5, so that's 7, a 1 for 8, and a 5, 13. And in my thousands column, I have a 1, a 1, and a 1, 3. So my answer is 3,375. Pretty crazy, right? And that trick will work with cubing any number between 11 and 19, and sets us on our way for a little trick that we're going to look at in another video, where we can look at how to find a cube between 20 and 100. Okay, so let's think about things to remember for this video then. Cubing a number is multiplying it by itself 3 times, and there is a trick for cubing numbers 11 to 19. Here are 3 questions for you to work on. Have a go at answering these. Put your answers in the comments section. I'm going to try and mark them all.
Okay, now we're going to start the first of our 3 rules. This first rule is the BODMAS rule, the order of operations. What order must we do these questions in to make sure we don't make any mistakes? Let's have a look at it.
Okay, so what is the order of operations? Well, the order of operations is a mathematical principle meaning the order that we need to do operations within a mathematical question. And we have this little term BODMAS to try and help us remember what order that is in. So let's have a look, and let's have a look at this question that we've got in the middle of the screen here. So our starting point would be here with the B, and our B stands for brackets. So the first thing we would have to work out in any question, if there is it, would be a bracket. Then our O stands for order, which is this little power of 2 here next to the brackets. And then the D stands for division. Our M is multiplication. Our A is addition. And our S stands for subtraction, but in this case we don't have any subtraction, but that would come last. Now in some instances you might see BODMAS down here where the I and the O are different, and in BODMAS it just means index. Same principle, it still means this power of 2 here, but it's just taught differently in different places. So BODMAS, BODMAS, exactly the same thing. Okay, so let's follow our order of operations and try and solve this question then. So our first order is brackets. So we're going to solve the question in the brackets first. And in my brackets I can see 12 divided by 3. Now, some of you might have noticed that our power of is connected to the brackets. But because it's not in the bracket, we're not going to do that at this stage. So I'm going to rewrite my next line, and it would be 4 plus. Now I can solve the brackets. So 12 divided by 3 is 4. And because now 4 is the only thing inside the bracket, I can actually now get rid of my brackets. It would be 4 to the power of 2 multiplied by 2. Okay, the next thing to do is the order, which in this case is this power of 2 here. So 4 to the power of 2 is just 4 multiplied by itself, so 4 times 4, and 4 times 4 is 16. So my next row would read 4 plus 16 times 2. My next one says division, and we actually don't have any more division in this question left, so I can move on to my multiplication. And my multiplication is this part here, 16 times 2. And the answer to 16 times 2 is 32. So my next row would be 4 plus 32. And I can now do my addition, and that's our last question actually. So I can now do 4 plus 32, and 4 plus 32 equals 36. So my total answer for this expression is 36. Okay, let's look at a harder one then. Let's look at this one here. And what's important to bring up now is that our division and multiplication and our addition and subtraction are linked. So although it says that our division will come before our multiplication and our addition should come before our subtraction, actually the case would be that if we get to a division or multiplication part, we would do it in the order that it's written. So if we were to look at this stage here, 4 divided by 2 times 3, I would actually start with my 4 divided by 2 because that's the first in the sequence. But if it read 4 times 2 divided by 5, then I would actually start with my multiplication because that's first in the sequence. So my division and multiplication are linked, and so is my addition and subtraction. So with that in mind, let's begin. And I'm going to start with this bracket first of all. Now in this bracket, I can already see that I have an order up here. So I'm going to do that part of the bracket first. So now my bracket would read 2 times 2, which is 4, plus 3 times 4 to the power of 2. Okay, looking back at my first bracket, there's no division in this question, so I can move to the multiplication. 3 times 4, which is 12. So I've got 4 plus 12 to the power of 2. Now within this bracket, I can finish off with my addition. And 4 plus 12 is 16, so it'll be 16 to the power of 2. And because 16 is on its own, I can actually get rid of that bracket, and I can simply work out 16 squared. And 16 times 16 is actually 256. So I'd end up with 256. Now I can move on to my other bracket, and I can see that in this bracket I'm going to have to work out the division first, which would be 4 divided by 2, which is 2. So I'd end up with 256 divided by 2 times 5 plus 2. And now in my next row I'm going to do the multiplication of this bracket, which is 2 times 5. So I'm ending up with 256 divided by 10. And now I've got rid of the bracket. And now I can see my question says 256 divided by 10 plus 2. And I'm going to have to work out the division first because that's first in my BODMAS before the addition. So I can do 256 divided by 10, which would be 25.6. And I'd have my plus 2. Now I'm ready for my final line, where I can solve the final part, the addition, and 25.6 plus 2 equals 27. 0.6, which is my final answer. So the final answer to this expression is 27.6, following my BODMAS rule. Okay, some things to remember then. So BODMAS can also be called BIDMAS. You might see it like that in some expressions, depending on whether we call it order or index. We must work in this order when solving any expressions. And then finally, the addition and subtraction, and then the multiplication and division, they are actually paired, and we would do those in the sequence that they appear in from left to right. And there you have it. That is everything you need to know about BODMAS.
Okay, hopefully that wasn't too difficult. We're going to get a little bit harder now with the commutative law, which is another law, very important law in multiplication. Let's go.
Okay, we're going to be looking at what the commutative property is, and we're going to be looking at these 4 example questions here and see how this rule or property applies. So first of all, we can think of the commutative property. Think of the word commutative like commute, which basically means to move. And what it's basically saying is that we can move our numbers in our questions and still get the same answer. And we can do this in both addition questions and the slightly trickier multiplication questions. So let's have a look what I mean exactly, and let's have a look at this addition question, 4 plus 6. When we have the question 4 plus 6, these two numbers are actually called addends. So we spell that like this, A-D-D-E-N-D-S. And it doesn't matter which way around we put these addends, we're still going to get the same number. Watch, if I put 4 plus 6, I'm going to get the answer 10. However, if I flick my addends the other way around and I put my 4 on the other side and my 6 at the start, add them still together, 4 plus 6 also equals 10. Let's look at it another way. If I have 4 balls, 1, 2, 3, 4, and I add 6, 1, 2, 3, 4, 5, 6, it gives me a total of 10. And it's exactly the same as if I have 1, 2, 3, 4, 5, 6 at the start, and 1, 2, 3, 4. I still get a total of 10. So addition questions are commutative. It doesn't matter which way around we put our question, we're still going to get the same answer. Let's have a look at it with this second example. 19 plus 100, 19 plus 100 equals 119. But if I flick my addends the other way and I have 100 at the start and I plus it to 19, I still get 119. And if I was a patient person and could draw out all those circles and balls, I could prove it with that model as well. Let's have a look at multiplication then and see if it works here as well. So 5 times 4. 5 times 4 is 20. But now my 5 and my 4 we don't call addends because we're not adding them. We call them factors because they are the factors of 20. And now let's see if I put these the other way around and put my 5 at the end and my 4 at the start. 4 times 5 also equals 20. Let's have a look at that with our footballs. And 5 times 4 can be shown like this. This array, as we call it in multiplication, represents 4 times 5. And 4 times 5 gives me a total of 20. But now if I flip this array around and put it the other way, this array now says 5 times 4. But we also now know that 5 times 4 still equals 20. So multiplication is the same. It doesn't matter which way round we put our question, we're still going to get the same answer. And let's demonstrate it with 8 times 11. 8 times 11 is 88. But also move mine the other way around. Start with 11 times 8. And 11 times 8 is also 88. So multiplication and addition are both commutative. It doesn't matter which way around we put the numbers in our question. Let's have a little think about subtraction and division quickly. Let's have a question, 5 subtract 3. 5 subtract 3 equals 2. Let's see if we get the same answer moving the digits around. And let's have 3 subtract 5. Well, 3 subtract 5, if I have 3 and take away 5, I'm going to end up in negative numbers, and I'm going to end up with negative 2. So I do not get the same answer if I flip these digits around in my question. So therefore, subtraction is not commutative. Let's have a look at division quickly. If I have 15 and I divide that by 5, I get 3. Let's move our digits around, and now I have 5 and I'm sharing it with 15. Well, this is actually quite a hard question to answer, but I know that my answer is 0.33 recurring, and again, definitely not the same answer. So again, division is not commutative. So addition and multiplication are commutative, doesn't matter which way around we put our numbers in the question, but subtraction and division are not. Very important to remember.
Okay, ready for our last lesson? Now we're going to look at the distributive law. And this is a bit of an introduction to the distributive law because the distributive law is actually very, very big and lots of little things to look at. We're going to look at the surface of it today and the first steps. So ready? Let's go.
So first of all, let's just think about the word distributive because it's a bit of a horrible word really. We can think of distributive like distribute or to share out. So what is the distributive property then? So we can look at a question like this first example, 14 times 6. And if we couldn't work out 14 times 6 or we didn't have time to do the written method, what we could do is we could distribute the numbers differently. And we could say that 14 is made up of a 10 and made up of a 4. And if I then multiply those individual numbers still by my 6, I can see I get 10 times 6 is 60. And 4 times 6 is 24. And then with my answer, if I simply add this up, 0 and 4 is 4, and 6 and 2 is 8. And therefore, I can get the answer 84. So this can become a very easy method of working out questions mentally. For example, if we have the question 432 times 5, this second example, 432 times 5 is obviously a difficult question to answer, but if I work out quickly what 400 times 5 is, then look at my 30 times 5, and then my 2 times 5, I can do those numbers quite easily in my head. 400 times 5 is 2000, 30 times 5 is 150, and 2 times 5 is 10. And now these numbers are quite easy to add up in my head. I can just add the 2000, the 150 and the 10 to get an answer of 2160. But that's not all that the distributive property is good for. It's also very good for these second two questions, of which this is meant to say 4 of course. So if we look at this first one first of all, 4 times 7 plus 5. I could work this out in the traditional way using the order of operations and understanding that I need to solve the question inside the bracket first. So 7 plus 5 is 12, and then 4 times 12. And 4 times 12 is 48. Or I can use my new distributive property, and I can understand that in order to do this I can distribute the 4 and multiply it by the 7. So 4 times 7 is 28, and 4 times 5 is 20. Add these two together, gives me a total of 48. And what you'll notice is it's the same answer in both of those. So the distributive property can be very useful for helping you understand and solve these expressions. Let's have a look at our last one. And again, we can use the order of operations and understand we have to solve the bracket first. 5 multiplied by 9. 5 9s are 45. Or I can use my distributive property and realize that I must first multiply my 5 times 3, which is 15. And then I can multiply 5 times 6 equals 30. Plus the two together equals 45. And again, same answer. So you can see how the distributive property can be very useful for helping to see the answer to expressions, especially when those expressions can get quite difficult. So there we have it. That is the distributive property within multiplication. Very useful for helping us with mental maths, but also to work out expressions. So what should we remember? Distributive is just a nice way of saying to distribute, or to share out, or move things around differently. Distributive property means to distribute or move the numbers around differently, and we can use this to help with mental maths and solve expressions easily.
Okay, hopefully this video was helpful for you. If it was, think about subscribing to the channel. Hopefully we'll see you in another video. For now, peace out.